Good afternoon, geographers from Year 10. This lesson really is all about sort of recapping what you've done since you've been at home with regards to your notes on the topic of coasts, GCSE coast geography. Okay, this lesson will be about coastal erosion processes and associated landforms. Okay, I'll do a little bit of talking. Okay, use the whiteboards quickly, but then we'll go into the field and have a look at some of them just outside my house down on the beach, okay, as I've done my daily walks and so on, and talk about the different features. Okay, so it's a bit of a mix and match, and hopefully will make you understand what you've been making notes on and doing the activities since you've been in isolation. Okay. Hiya, so we're going to look at coastal erosion processes and landforms. Jack, if you could just come around here, you can see the pages that we're going to look at, okay? And you can get a page in your book, get some notes, okay? So when we first started, okay, this was in the lessons we did 92, 93, we talked about what causes the landforms and the processes. So I've taught you about waves, constructive and destructive waves, okay, and how they shape the beach and so on. We then talked about there's two ways that the cliffs are worn away, they're eroded. You have weathering, so you can write this down as we go. There's weathering, or what are called subaerial processes, okay? Subaerial processes, A-R-I-E-L-A-L, all right, okay? And that's physical and chemical and biological weathering and so on. And we get sort of processes like, for example, freeze-thaw weathering. That's one of the main ones. And you get the wetting and the drying of the cliff, which causes cliff collapse. Okay. Also, we get salt weathering as well. Okay. And that's on page 95. And you've got these sheets at home. Okay. And also carbonation, which is another one where the carbon dioxide gets into and mixes with rainwater. It's like weak carbonic acid there, okay, and dissolves the rock. Really, it's like chemical weathering. So we have physical weathering and chemical weathering. Okay, physical is also under the umbrella of biological weathering as well, where you get roots growing through the top of cliffs and splitting rocks apart. Okay, and then you've got like cliff collapse. Okay, and then the other processes. So weathering makes the mess. Erosion sort of cleans it up and moves it all away, and you've got the processes of solution. That's on page 96. Corrosion. You need to know what these mean and what the terms mean. Abrasion. Attrition. Okay, and the classic hydraulic action or hydraulic power. Corrosion and corrosion. It used to be corrosion. Corrosion used to be the one which talked about solution. Really, corrosion was also solution, but I think they've changed it to make it simpler. And so basically, you've got your solution, corrosion, abrasion, attrition, hydraulic power. Okay. Now all those act on the cliff. Okay, and they form a series of different landforms. They move the material, you get deposition and transportation, okay, 97, okay, which we've talked about. We have a bit about wave refraction, which you'll see on the footage when we go out in the field. I talk about wave refraction, okay, have a read of that, okay. And then we've got different features. We've got the headland and bay, okay. We've got cliffs, wave cut platforms, and these are all erosion landforms that form because of this, okay. You've got caves, arches. Don't see any arches at Widmouth really. We see lots of stacks and stumps. Stack, the famous one, Black Rock, okay, and I'll point that one out. And then from that you also get other landforms, so they're the erosion landforms. And the other landforms that you get, which you need to know, be able to describe, explain, have a case study of, okay, describe and explain the formation of, and you need to know all this, okay, and you hear that there's different little activities you can do here to test yourself, okay. The question is based on this, have a look. So we've got headlands and bays. Then we've got the sort of like deposition landforms. That's when the sea sort of like calms down and things get dropped after the transportation of the prevailing winds pulling the sediment across. You've got beaches. We've got lots of beaches at Widmouth Bay. Okay, we've got lots of sand dunes. Okay. We don't have any spits. We haven't really got any bars. So you can look at those in your notes, page 101. But those two, we've got quite a lot of Widmouth Bay. Okay, and the sand dune notes here are useful. So look at your page 100 at your notes. Okay. Nice case study here. That's for you to read about different types of coast. You get concordant and discordant coastlines. We're really quite concordant. You run parallel to the sea. But there are other parts of the country which are discordant, where you get hard and soft rock. And all these formations, these ones here, are formed by what is called differential erosion. Erosion going at different rates. Okay, soft rock goes quick, hard rock slower. Okay, so that's it. Okay, you can look at this as well. It's another place, Swanage, use that. And then the next clip, I'm going to do all about humans and how they impact on the coast and what they do with a hard and soft approach. But we'll go back, we won't do that yet. That's next YouTube clip. Okay, so we're now going to go into Widmouth, going to walk out to Widmouth. Okay, Widmouth Bay is the rocks are made of upper carboniferous shales, sandstones, mudstones, sedimentary rock, layers of rock. Some of it's soft, some of it's hard, and that's why you get lots of this differential erosion. About 310 million years ago the rocks were made, and it's part of the Bude and Crackington Formation. Okay, so the Bude and Crackington Formation, 310 million years ago, sedimentary rock. Because of sedimentary rock, what you tend to get is hard rock, and you tend to get soft rock. Okay, parts of it are hard, like lines of shale, and you get like the wave cut platform sticking out. Then you get the softer rock in behind, where you get like caves and you get bays formed, and there's different types of bays. And so we're going to go out in the field, go on a daily walk. We can go out and I'll show you where all these different features are. Okay, but make notes on these, then go back and look at your pages from 90, 91 right through to 96, 90, yeah, all through 91, really, 91 right through to 105. This is all about. So listen to what we do out there, okay, and then go back and read these things and apply those activities. Okay, lovely. Afternoon, Year 10. I'm stood at Wanson Mouth, which is just south of Widmouth Bay, and I want to talk to you a little bit about the coastal erosion processes and weathering processes that work. They act on the cliffs to cause collapse. Here we have freeze-thaw weathering, which goes on during the winter generally, where you get the cold and the ice expanding and causing it to collapse. You can look in your textbook to see how the process works, but it creates frost-shattered material like this, that falls down and breaks. And that's not really the sea doing that. It's not a marine process. That's just like the wet and the wind. It's like a weathering process. And also you have biological weathering, a physical weathering as well, taking place in here. You can see roots growing through the cliff here and pushing and breaking up the roots as well, and breaking up the cliff. So this is sub-aerial, this is weathering going on, okay, as opposed to what you get as well, which is the marine process, which is the act of the sea. See the sea over here. It's on a big high tide, it'll go against the cliffs and it'll erode and wear it away, like hydraulic action, abrasion, attrition, corrosion, abrasion. You can also see the erosion landforms here as well. Here we have the wave cut platform, the rocks. Okay, you can see that rock, it's just one big lump of rock, and that's the line where the cliff used to be, and over thousands and millions of years it's gone backwards. It's eroded backwards, slightly up, so you have this cliff here, and you see the strata in that cliff as well. So here you have at low tide, you don't really see them, but at high tide you see some stacks and stumps here at Watson, poking out there, the top there, and then further up there you see the large one, which is black rock, which is a large stack as well. But what I want to demonstrate really is this sort of sub-aerial process, the wetting of the cliff causes it to collapse. You get cliff collapse, as well as what I'm trying to explain to you is that cliffs don't just erode by the sea, they erode by the weather, by weathering processes, breakdown of weather in situ. Weathering makes the mess, and erosion clears it away. Okay, nice one. Hi again, this is at the water's edge now of Wonson, and you can see down here, the closer you get to the sea, the smaller the material, the more round as it is, as it's been eroded and touched by marine processes like hydraulic action, attrition, abrasion, corrosion and corrosion. Rocks bang against each other through the sea, and they get moved about, they get transported and they bang into each other, get smaller and grind down to eventually end up looking like sand. And you can see the sand here too. Okay, but so it's small material here. As you go further back, it becomes bigger and more rounded, more angular, more rounded towards the water's edge. And you can see those cliffs, those lovely strata in the cliffs up there. See all the lines from all those strata. There's sedimentary rocks being compressed over great heat and pressure over millions of years, and created these lines like sandwich lines, really, like sandwiches. And the pressure of the heat, plate tectonics has bent them into faults and fault lines. And basically, you get these lovely strata in the cliff. It's well known around here. Around the corner is Millet, just a bit further south, and that's well known for the sort of strata in the cliff, the lines of the joints in the bedding plane, the stripes in the cliff, which you can see. Okay, but it's quite good to show the weathering in the top of the cliffs, and that causes the problems, like I said earlier. All right, okay, this is the bit further south, away from Wonson, walking towards Millook, and you can see the wave cut platforms, the perfect dark line now at low tide, where the cliffs used to be. So you can look at the cliff line. If you look at the cliff line, you see the brown layer at the top, and that's called the regolith. That's the sand and the soil and the rocks all together. It gets wet, and you get weathering going on where you get collapse as well, which can be, that's often the problem there. And then you have your storm beaches at the bottom, okay, and the sorting of sediment, okay, and in the distance you can see the bay, and obviously sweeping bay, but on a larger scale, all of this is one massive bay going out towards the satellite dishes towards Morwenstow. Right in the north there's a real protruding headland out there, right through to the other side, which is like Dizzard Point, and you can see the soft rock going back and showing you the different landforms again. All right. Okay, so behind me here is Millook. This is the first bay there that you can see there. The waves hit there and they bend in. It's called wave refraction. And if you look in your textbook, in your notes, you can see how wave refraction works, and the waves come in, they pull in the sediment onto the beach down at Millook Haven. If you haven't been there, go and have a look. Okay, so that's the first sort of clip about erosion landforms and erosion processes at Widmouth Bay. It's a good case study. Differential erosion, think about all those key terms. The next clip is all about humans and how they hold the line and they sort of slow down erosion, which is, we have the hard and soft approach, and I'll talk about that next time, but still apply it to Widmouth Bay. All right, so you get the idea. So sort of like geography in action, really, rather than just the notes. So you can look at the notes in your book and the sheets that you've been given, okay, but then you can see how it's applied in here. Okay, thanks for listening.